Okay, so hello everyone. We're back today for the second session of the thesis defense of the MARRES master thesis defenses. Today there is two sessions. The first session that will start now is about coral and society. And so you will meet Julie Pezin, Aliyya, Lathifa and Florina Jacob. Julie will talk about coral restoration, a coral restoration study with mineral accretion technology. This is in Seychelles. And Aliyya will also talk about coral restoration using Biorock systems, but this time in Indonesia. And we will finish with Florina Jacob, who worked with Coral Guardian in France, but the place of study is also in Indonesia, talking about a study, an assessment of a protected and restored coral ecosystem with local communities. Then we will have a break and we will talk about the next session. The next session will be about ecosystem services. And this time, Matthias and Richard will come. So Matthias Crisostomo worked at Monaco, but the place of study was the Maldives with Nathalie Ilmy. So he worked on the socioeconomic impacts of climate change on, of course, the ocean, the policies we can adopt, but also on social perception in the population there in the Maldives. And finally, Richard Singroy was in Sweden, but the study location was in the Indo-Pacific. He worked on intertidal gleaning, so a type of local fisheries. So intertidal gleaning and seascape configuration there in the Indo-Pacific. So we will start with Julie. Just before we start, I can introduce you to the jury members. So today we have two jury members on site. I am not a jury member. I will just try to make the technical things to work, which is sometimes difficult. So online, so if we have a look on the Université Côte d'Azur jury, we have two representatives from the IRCAN lab, Eric Rottinger and Aldine Amiel from Line. They're working on developmental biology, regeneration, cellular and molecular biology, stress response, cnidarians, and aging. I think you know them, Julie. As a neighbor, Steve Como, who is here on my left, is coming from Villefranche-sur-Mer, IMEV, is a laboratory from Sorbonne. He's just back from the Arctic. Tu sais quoi? She knows you too, yes. Stéphane Roberti is coming from, but he's there at the Université de Liège, specializing on reef building corals, marine symbiosis, photosynthesis, and homeostasis. Ninian Müller, hello. You're coming you're at Sign Planet, you're a researcher there. And your field is maybe more education, ocean literacy, and also use of virtual reality for conservation in ocean literacy. And we also have here on site Jean-Vincent Vieux-Ingrassa, who is actually coming with an external point of view as a science teacher, a biology teacher at high school. So pay attention, Julie, questions can be different coming from So Julie, you can actually start. Julie, for you to know, is actually so in the Seychelles. You're staying here for quite already a while because you will stay there for 1 year. It's a 1 year internship. And as you're in the Seychelles, but maybe before we start, what's the time in Seychelles?
It's 3 o'clock.
3 o'clock. Okay, because later we will have someone who is currently in Chile. So the jet lag is quite interesting this afternoon. Julie, as you're with the distance, you will control your PowerPoint. So maybe you can start sharing your screen.
Yes. Do you see it properly?
Yes, we see this fully properly. So Julie, you're going to have 15 minutes to present. So maybe make sure to have a countdown with you.
Yes.
Your phone or something. And when you're ready, you can start. Good luck.
Okay, let's start.
Allez.
So, hi, I'm Julie Pezin, and I did my master thesis on a mineral accretion supported core restoration project to investigate the effects of maintenance cleaning and electrification schedule on 4 hard coral species in Frigate Island, Seychelles. So Frigate Island is located in the Indian Ocean, and since the past 40 years, some conservation efforts have been made on land and more recently underwater, like our project. And if we come back to our title, so mineral accretion supported coral restoration. First, coral. A coral animal is a polyp. It has the ability to produce a calcium carbonate skeleton, and it also has the ability to form colonies, making what is called a coral reef. And a coral reef is actually the largest biological construction you can find on Earth. And corals have a high value. First, they are almost 400 times richer in species diversity compared to any other ocean habitat. And that makes them a really important reserve for tomorrow's medicine. They are also really important for fisheries, since fisheries directly rely on the health of nearshore coral reefs habitat, and especially since it represents a big part of Seychelles' economy, just as snorkeling, diving, or leisure fishing. Coral reefs also provide ecosystem services, such as coastal protection. But corals are under threat due to ocean warming and ocean acidification. An increase of 2.7 degrees and decrease of 0.1 to 0.4 pH units are expected at the end of the century. And since the precipitation of calcium carbonate skeletons directly rely on temperature and pH, it really strongly affects calcification processes. In the Seychelles, in 1998 and 2016, some mass coral bleaching events already occurred, leading to 90% mortality at some sites. But some action has been made to mitigate the effect of the pressures, such as the restoration of degraded ecosystem, which is coral restoration, for example. But also more recently, since the past 10 years, some active coral restoration, which are quite different because it consists in helping corals to grow after transplantation. And one of these techniques consists in using low voltage electricity and is called mineral accretion technology. So that leads us to our title, Mineral Accretion Supported Coral Restoration. So let me explain you how it works. So first, you have an electricity source on land, and underwater, you have an anode, which is the pole plus of electricity, and then metal structures, which are our tables, and that act as a cathode with the pole minus. And when you connect them together, it produces an ion field. And this induces the electrolysis of seawater, and so the production of hydroxide ions at the tables. And this enables the production of calcium carbonates. And also locally at the cathode, you will have an increase, an elevation in pH, really locally. And all of these enable calcification processes. So this technique has already been used all over the world by some teams. But even if it works, we still really don't know how to use it in the most efficient way, because the idea is also to use as less as electricity as possible to find the better growth, better support. And we want to understand really how to make it more efficient. And that leads us to our research objective. But first, I want just to show you how it looks like. So here, for example, you have the metal structure, so the rebar, which is on the cathode. And with the dissolution of minerals with this ion field, it would lead to the production of this calcium carbonate crust all around the structures. But let's come back to our objective. So now this works and we want to optimize it. So we want to understand what are the main factors that optimize the performance of mineral accretion technology to support coral growth, health, and survival. This experiment is supposed to last for 1 year, but for this presentation, I'm only able to show you the results after 1 month of experiment. Our study site is called the Airport Reef, and it has been chosen because it's a coral rubble field, which is really good because it enables the installation of the structures. So it's quite useful, and also it's close to the shore, which is really important for the electricity source, which is provided on land. But it is also deep enough, between 12 to 13 meters, which is important to reduce the effect of tide and waves. The main factors we're looking at are the electrification schedule, the maintenance cleaning, and the species. More specifically, we want to see the difference between fragments that are untabled but are going to be not electrified compared to electrified 12 hours nighttime, compared to electrified 12 hours daytime, compared to electrified 24 hours, so continuously. I'm just introducing you to those abbreviations and color codes that will be mainly used in the figures that will follow. The second factor we're looking at is the maintenance cleaning. So I want to compare the fragments if they are on table that are cleaned versus not cleaned. And finally, we want to see if there is a difference between species. And so we have chosen the 4 most common species found around Frigate Island, namely Acropora muricata, Acropora abrotanoides, Acropora vermiculata, and Pocillopora meandrina. The variable response we are looking at are coral growth, health, and survival. For the coral growth, we are measuring the length and the width with 2 different methods. First, by taking direct in situ measurements, so measurements directly on the field, and secondly, also by taking digital photographs underwater and analyzing them on land. For the health, we are stating if the fragment is healthy, 100%, to dead, 0%, with the Coral Watch health chart. Finally, for the survival, we just state if the fragment is alive or dead. So this is our experimental setup. So it is made of 40 tables put in a big circle with 3 anodes in the middle. So we have 3 anodes because we have 1 anode per electrification treatment. So we are going to have 1 anode electrified 12 hours nighttime, 1 anode electrified 12 hours daytime, and 1 anode electrified 24 hours. And each table is, each anode, is connected to 10 different tables put all around the circle. So this, for example, is for the night condition. So it's with 10 different tables. And so we will have some night table, day table, 24 table, and of course, non-electrified table that are not connected to any anode. Half of them are cleaned, half of them are not cleaned, making 8 different treatments. And each treatment have 5 replicates each, making the 40 tables that you have seen previously. For the direct in situ measurements, like I told you, we just measure the length and the width. For the photograph, it's slightly different. We take a top-down photograph and a side photograph. For the top-down, we measure the longest length and the width, perpendicular to it. But for the side photograph, we first need to draw a reference point and then measure the longest length and the width, perpendicular to it. This reference point is obtained by removing the crust that I showed you earlier at some parts. So it allows me to draw lines that are really next to the initial rebar that was put. And this is how it is obtained. Now that you know all this, let's have a look to the results. So in this graph, you have the temperature in degrees and the time in weeks, with the blue line representing the surface temperature and the orange line, the bleaching threshold at 30.5 degrees. The transplantation was made on the week of April 11. And as you can see, on the 2 weeks that followed, a marine heat wave occurred. And by that, I mean that the temperature was above 30 degrees and even above the bleaching threshold just after transplantation. So that really put the experiment at stake. But let's have a look at the health condition of the fragment. So here you have the health condition in percentage, with 0% for a dead fragment, 100% for a healthy fragment. Each dot represents one fragment. And you have the non-clean tables here and the cleaned tables here, and all the electrification treatment and the 4 different species with the color code. And first, what we can see is that globally, less than 5% of the coral fragments have been impacted. So that's a good result. And that tells us that the 4 species seems to be suitable candidates for coral restoration projects. And then we have seen that apparently the fragments that are dead mostly belong to the non-electrified table. And so it seems that there were a positive effect of mineral accretion technology on the health condition of the coral fragment. And we think it's due to the fact that with this white crust that goes around the table, it really forms a kind of banded, it really attach firmly the fragments to the table and making a better survival. Now let's have a look at the growth rate. So here we have the growth rate in days for still the non-cleaned and clean condition. And there's a different electrification treatment for the in situ measurements and the photograph measurements. And we can see globally that in situ measurements always gave higher growth rate compared to the photograph measurements, and with even significant difference. And we think it's due to the fact on the field we make an in situ approximation of 0.5 centimeter, and that after 1 month, this can be a big difference. However, this observation was not made for only one treatment, which is a non-cleaned, non-electrified tables. And we think it's due to the fact that for the photograph, so we did this reference point by removing the crust, except for the non-electrified tables, and that the tables were cleaned, except for the non-cleaned. And so that the non-electrified, non-clean tables were the only one where the deposition of a thin algae layer could have actually influenced the drawing of the lines. And then this could be an experimental error. So after these differences, we have decided to stick to the in situ measurements that are most commonly used in coral restoration monitoring. And this is the same graph. So the growth rate with non-clean and clean, and there's a different electrification treatment, but this time for the 4 different species. And we have seen that Poecilophora meandrina was significantly different at the growth rate, significantly different from all other species. And we think it's due to the fact it is dome shaped. So even if it's a branching species, it grows radially. And so maybe that's why we recorded a slowest growth rate. And also Acropora species are usually have high growth rates. But globally, if we look at each species individually, there is no significant difference between treatments, or either cleaned and not cleaned, or electrification. So after 1 month, we can say that it seems there were positive effects of mineral accretion technology on the health condition of coral fragment, that the fact we didn't clean on one table led to an experimental error, and that the 4 species are suitable candidates for coral restoration projects. And even after 1 month, the growth rates significantly differ between species. After 1 year, we expect that coral fragment under the treatment 24-hour will outperform other treatments, and that coral fragments under the treatment day and night will still outperform the non-electrified. And so that could be potentially used as well for core restoration project, even if it's lower. We expect that coral fragment on clean tables will outperform the non-clean tables, and that some species will respond more positively than others due to innate physiological characteristics. I'd like to thank Aliyya Lagoli, founder and director of corallife.org, Dr. Joan Wong, scientific advisor of corallife.org, and Anna Zora, head of Frigate Island Conservation Department, that helped me collecting all the measurements. Also, I would like to thank the MSc MARRES, and especially Christophe Moquet, director of the MSc, but also Paola Furla, Barbara Pourreau, Aldina Miel, and Crystal Moreno that helped me for this project. Thank you for your attention.
Thank you, Julie. Bravo for your presentation, for the nice presentation here. So you're still in the Seychelles. So here it's also quite warm. We also have the song of the cicadas. So it's already summer here. So it's warm. We can start maybe the questions. So this 15 minutes question session with Aldine. Aldine, are you here?
Yeah, I'm here. So thank you so much. Did you stop? Okay. Thank you so much, Julie. It's a really great presentation, and your project is really amazing. So my question is more related about your different condition regarding the other biodiversity around the coral colony. So I know that it's really young experiment now, so maybe you will have this answer for later on, but do you start to see other biodiversity coming, I mean, other animal coming around, or do you start to see a difference between your different conditions?
So to assess the fish communities around the study site, we have done it prior to the installation of structures, and we want to do it after. But for now, we have done it after 1 month, and visually we can see that there is more fishes around. But on the papers, when we're doing the census, it's not really clear, it's not really big, because on some corner of the circle, there are a lot of reefs. And so it really influenced a lot the census that we're doing. So we expect to see more differences after 3 months. So that's what we want to do now. But visually, we can say that there are some fishes coming around the table, underneath the corals, underneath the tables as well. So
and all the encrusting algae?
Yes. So for the encrusting algae, it's more around 6 meter depth. Here we don't really see it. We have some green algae mostly, but are quite easy to remove with the cleaner.
Okay, thank you.
Thank you, Aldine. Here we go with Eric, maybe. Eric, sure. And then it's going to be Steve.
Okay, nice presentation, Julie, and nice work, very interesting. I have actually one or two questions, if I may. So you said that the pH is slightly increased when you do the electrification. My question here is, do you know if somebody has done this kind of experiment at different pH conditions, and do you create always the same pH environment locally around it, which favors potentially the biomineralization?
So since the past 10 years, so all the different electricity put for the experiment have been tested, whether more or less. So everything has been done. And so we have different elevation in pH locally. Usually it's always approximately the same, because when you use high voltage electricity, it works. But the skeleton is mostly made of brucite instead of aragonite. And so it's not good for the coral. So we try to keep a low voltage. And so the difference in pH is really local and very low.
Okay. It was interesting, but it was not, perhaps I didn't really phrase my question correctly. If you put the whole experiment at a low pH, because that's a problem of future ocean acidification, if you put it at 7.2, or if you keep it at 8.2, at the end, is the closely related pH levels, is it always the same at the end, or do you just I don't know how to phrase it. Do you have just a delta, or do you always come back to the same 8.2 level?
No, it's not really precise elevation in pH at all. And especially due to the gradient, sometimes it can vary and it's not going to be the same even for the same fragment on the same table. I mean, for different fragments on the same table. It's not really stable at all. So it varies a lot. With just some studies have showed that the difference in pH was quite consistent with always higher pH, but it's quite hard to keep it at the same level or decide we want to keep it that way. It has not been done yet.
Okay, and then I have another question, if I may. Do you know if somebody looked at the genetic variability in if there is one genetic background of the same species that is more prone to respond positive to this kind of approach, or not? No. Because it's already a work in the coral restoration where people look at sort of more resistant corals. And my question here is it more resistant and more prone to respond positively?
We don't really know for now. For each experiment that has been done, there are some species that respond well and some that respond, but there is no response, and some that respond badly, even with a negative growth rate under these treatments. Even now, the 4 species that we have chosen, we don't really know if they are going to respond well to the experiment. And there were especially same experiment or slightly different experiment on the same species to try to understand if it was just the experiment itself or it was really the technology. But for now, no, there is nothing that can say that a species or another could respond more good to mineral accretion technology.
Okay.
Thank you. So we can go to Steve and then to Florian.
I have a long list of questions, but I will just ask you. First question is like your initial results show that basically there's not much of an effect of the electrical currents. So where do you draw the line? You know, at the end of your experiment after 1 year, when do you think it will be successful? Let's say if you have an increase of like 5% in growth rate when you apply this current, do you think that it's a good restoration tool, or it's not enough actually to have to, you know, make all those efforts to apply these electrical currents for such a small effect on the growth or health of the coral? So how do you deal with that?
So usually with this technique, we are supposed to see 4 times faster growth compared to the non-electrified. And it's supposed to be in the first month, actually. So after this month is quite tricky due to the measurements. But actually, after 4 months, the crust is so thick that actually the electricity is not having such an impact. So we really expect that after 2 or 3 months, we're going to have a big effect, which is going to be more than we expect, 5% more. We expect to see really big differences. And like you said, indeed, the goal also is not to do it just to have a small amount. And that's why we're also testing if we can use less electricity, but it's going to last longer maybe. So it will support longer support over time. And but we expect to see really a big difference, not just 5%.
Okay,
another question.
Okay, another quick question maybe. So what do you think would be the benefits of this method compared to other like, you know, restoration method or method to change the chemistry of the water, such as like, you know, alkalinization of the water, for example, which can probably be done in much larger scale than this method?
Actually, we have seen with the just first result, a big thing with coral restoration is the transplantation itself that can really impact just the health of coral and the fact that they're going to recover. And especially in some times where we're going to have more and more marine heat waves coming, so it might be tricky. And we've really the fact it's firmly attached to the structure and that it really makes it good also for the settlement of larvae after a certain time. We expect that we're going to have over time a better connection. And the thing which is good is that we expect to remove it after a certain time, just when the coral is well established on the tables, but there is a good substrate for larvae settlement, we can just remove the technology and put it somewhere else. And this actually is going to be in really large scale restoration project, especially with corallife.org, which is going to make with like a lot of tables. I cannot say much, but this can be really a large-scale project.
Okay, thank you.
Thank you, Steve. So we can go to Florian, then it will be for Stéphane.
Yes, thank you, Julie, for that interesting presentation. I would like to see the background, you know, what's behind you, right? It's pretty sunny here, so it's okay.
Actually, Julie found the background the closest to the MARRES color, if you can see behind you. So thank you, Julie, for that.
Of course.
Very nice. Well, yes, so I'm not too much of a coral expert, so my questions is more going to be about the methodology for the measurements and all the countings. I was wondering if you had like any computer routines or like MATLAB tools or stuff like that, or if you are just like measuring with a certain software. So that will be my first question. Second question is, have you guys thought about using the photogrammetry technique, which you take quick snapshots, photographs along a transect, so it takes more time on the site, but you can have like a surface model. So then when you overlap various dates, you can really see like the growth and the evolution. We do that for the dikes at Accretion. And well.
Okay, great. Thank you, Florian. So for the measurements, I'm using ImageJ and I'm doing everything manually. So for now, it's just how it is. But for the mapping, we had some, actually, we had the idea of doing a mapping every month of around the tables and to use it with Agisoft to do a mapping. And then we wanted to use a machine learning, which is called Kyoto, to find, just to separate between dead and survival and to find the growth. We didn't have time to do it yet. We were trying to get the technology to do it as well. Even if it's small stuff, even just to have the weight with the good thing on it, it's quite tricky here. But we really want to do it. For now, our first stages, because we don't have that much fragments, it's actually not really useful to do big scale like that for our project, but we really want to investigate, because for future large scale, it could be really interesting.
So proof of concept for now, I guess.
Yes.
Okay. Well, just one last quick, tricky question. How do you estimate the error in the georeferencing of the image? Because you have your point of reference. So do you think there could be a little error in that? How would you, how much? Like a millimeter? You have an idea?
Of course, there are some differences, and but we are trying to get a lot of cues with the tables. We try really to use the tables as a cues. When there is a rebar, we try really to have it as a fragment in the middle. And the more tricky for the side photograph is the angle when we take it. So we try really to have it as perpendicular as possible. But that's also why we get these reference lines that try to also tell us. And with time, we will see if it's consistent or not. That's why for now, really field measurements are our go-to, but we are investigating this new method, which actually takes a lot of time as well underwater, but is more easy to handle in rough sea conditions and stuff like that. So that's interesting to try.
Sweet.
As
well, thank you.
Okay.
Thank you, Florian. So Stéphane, and then it will be Nina.
Thank you. Thank you for your presentation, Julie. So I have a quick question. Do you know if the calcification rates are changing in the corals according to the day or the night? And if yes, how do you expect it will impact your treatments, night, day, or 24-hour treatments?
So we think that due to their physiology, we will have higher growth rate during the day, but we are really not sure depending on the corals. So for now, we kind of expect to have first the 24 hours, then the day, then the night, then the non-electrified. But between the day and night, we are really not sure of what will happen, because we know that some corals are going to assimilate during the day and maybe calcify during the night. But we don't know if in the night they will calcify if they didn't add it during the day. So we are not really sure about that, I must say.
Okay. But that was just one quick question if I have time, but otherwise I will keep it for me. Okay, so what is the difference between mineral accretion technology and the Biorock technology? Is it the same or?
It is the same, yes. Just Biorock is using mineral accretion technology to make the coral grow. It's kind of, it's just a brand, Biorock. So it is a company that only does that for coral restoration. And mineral accretion technology is just a concept that is also used for other types of things like research.
Okay, thank you.
Thank you.
Thank you, Stéphane. I think we're going to hear again about Biorock soon, Nina, and we will finish then with Jean-Vincent.
Yes, thank you very much. That was really interesting. I really enjoyed your presentation. And also I had to scratch all the questions because they were already asked, so it's quite hard to be one of the last. But one question I have, because you said you did all the photo analysis yourself, I think, right? Do you do all the measuring yourself on site and later on, or are there other observers, and how do you then do observer bias?
So for all these measurements, for the three first months, I was alone with Anna, so the head of department that I introduced before. So because of COVID, we were really a short team. And so we did all of it by ourselves, which was not that bad because it allowed us to be sure about what we were doing and to have a consistency, which is really important as a first month of experiment. Now, since like a couple of days, three new person are joined the team. And so we are training them to be able to continue the data.
Okay, and are you also going to then like note who was monitoring what so that you can keep track on it?
Of course, yes, of course. But I must say I'm going to try to keep as much as possible Anna and I, because there is too much factors that can influence the data. So, but we need, of course, it's a lot of work actually. I don't think we really realize, but it's minimum of like a 16 dives if we just look at individually what someone could do. So it's really weeks of only taking measurements and cleaning and using pliers for the reference points. So we need a team anyway. And of course, we would like to make sure that there is no big differences.
Thank you.
No, thank you.
Yeah, I think it has to be clear that that's a lot of work behind this. We were monitoring you from the distance, of course, with Christelle and Juliette. And Julie was always diving. I don't remember how many times a day. And I just want to pinpoint this, that for those who are diving sometimes multiple times a day, like maybe Steve here or for you, it's really exhausting. So finding the time and the lucidity to do science at the same time, it's impressive. We'll finish with a question with Jean-Vincent.
Yes, did you hear me well?
Sorry?
Did you hear me good or not?
I cannot catch the word.
Okay, do you hear me?
Yes.
Yes, okay. I have two concrete questions. First, should this technology be maintained permanently or arrived at a certain recovery, we turn everything off?
So the idea is to be able to shut it down. And I think with the past studies that after 4 months, it should be enough, since with the crust anyways, there is not going to be an effect. So this experiment is for 1 year, of course, because it's a scientific experiment and we want to push it and to have a real answer. But to my opinion, I think after 4 months, we should shut it down and place it somewhere else.
Okay. And the second, if we want to recreate large reefs with this technique, wouldn't that make a lot of submerged material, like too much?
Of course, but usually it's on degraded areas, and the metal structures don't use that much alien material, such as plastic that could be used or car tires before. So on a degraded area, using some metal structures for some time, but after are going to be straightened and replaced by calcium carbonate substrate, I think that's a good thing to do.
Okay, thank you.
Thank you, Julie. So that's it. Congratulations. As we said in the beginning, actually, you are only at the midterm of your internship, of your experience, at least there. So you have more than 6 months left there in this little paradise, really little paradise. So good luck for that. And I'm sure we'll keep in touch with you to know your adventures there.
Thank you so much. Thank you, everyone, for your question and for listening.
Salut, Julie. Good luck.
Bye.
So we will continue here just in a second. I guess Aliyya is going to enter quite soon here. Oh. Aliyya? Yes. Hello, Aliyya is coming. Hello, Aliyya. Alors,
where am I?
yes. Let's be. My mask. Sorry, I'm sorry. Thank you. It's live stream. So. So you're going to be able to remove your mask during the presentation, which I told you. So here you're going to not see you, don't worry. You're just going to have from your presentation, just a few things that here you will have maybe 1 second of delay for the presentation. Here is the little remote, so you can easily switch from one to the other. Last thing, at the end, during the questions, you will have the jury members also here, so you can directly look at the panel. Okay. I agree. So, come back here. And
sorry, I forgot timer.
Yes, time. I was going to tell you, don't worry.
So I can just start?
Just hold on. I'm just sharing the screen so that the jury and everyone can see your presentation. And I'm just asking for maybe Aldin, if you can see the presentation quite well with the distance.
Yes, no problem.
Oh, okay, thank you, Aldin. We're good to go?
Okay.
Allez, let's go for the 15 minutes.
So, hello and good afternoon, everyone. My name is Aliyya, and today I'm going to present you my thesis that I'm doing with Biorock, Indonesia, which is called Guidelines Recommendations based on the biological surveys in Sebalang village, Indonesia. And before I start my presentation, I would just like to mention that because I started my internship late, so this work is still currently ongoing. So the results and discussion that I'm going to present are not fixed yet. And so this is the outline of my presentation. First, I'm going to do the introduction, next the methods, and then the expected results and discussion, and then the conclusion. And so coral reefs are some of the most valuable ecosystems found on Earth. They can be found in more than 100 countries with 500 million people rely on them for their livelihoods. They provide a lot for the communities, such as coastal protection, benefits from fisheries and tourism, and also food supply. And Indonesia is one of the countries that rely on this ecosystem for their livelihoods. Its warm tropical waters throughout the year makes it possible for coral reefs to thrive. However, despite the benefits of coral reefs, the condition of coral reefs are degrading because of factors such as natural disasters, for example, earthquake and tsunami, but also because of anthropogenical factors, such as overfishing and the use of destructive fishing gears. And coral reefs are able to recover. However, it depends on the frequency and also the intensity of the pressure itself. And so to prevent that, to prevent coral reefs from degrading any further, rehabilitation is needed to prevent further loss, to improve recovery, and also to improve the livelihoods of the communities. And founded in 2015, Biorock Indonesia is an NGO that specializes in coral reef rehabilitation in Indonesian waters. And the name Biorock itself, or also known as mineral accretion technology, Julie's subject before, is a technology that involves running low voltage to a marine structure. And one of the most recent projects that was done by Biorock Indonesia was located in Sebalang village in Sumatra, Indonesia. And so a lot of people there work as fishermen. However, they used destructive fishing equipment such as bombs and also potassium. So it caused the environment to be degraded. And for this reason, to improve the environment and also the communities, Biorock Indonesia held a coral reef rehabilitation program working together with PLN, which is the state electricity enterprise in Indonesia, as part of their corporate social responsibility program. And to do the coral reef rehabilitations, surveys were done, surveys which included fish abundance and also substrate covers were done. And so these surveys were done in October 2020 and also April 2021. So the first survey was done to act as a baseline, so to know the initial condition before the coral reef rehabilitation takes place. And then the follow-up survey is to monitor what happens after rehabilitation was done. However, there were some inconsistencies found during data retrievals, making us unable to have a before-after comparison. In fact, right now, there is no standard operating procedures to perform fieldwork data collection. And so first, like I've said before, we're unable to make before-after comparisons. And also in the future, it might help to have proper guidelines, might help the NGO to work more efficiently and also to minimize any indecisions that might come. And so it brings us with the aim of this work, which is to search for the best guidelines to enhance Biorock Indonesia's work, to have standard practices for different project sites. And the hypothesis of this study is that the current methodologies used for field surveys now are not appropriate to highlight the data. And so the methods I'm going to be used comprise of two main things. The first one, the data from the surveys were observed and then the differences were noted. And so it's not only about the methods itself, but also the details like the location, the depth where the data was taken, the number of transects, the length of the transects. And next, bibliographical work was done to find the most suitable parameters that we can have. So the methods want to see what are the limitations and also the advantages of this. And next, for the results, we want to compare what are the different data that were taken. But before, I want to show you how the data was taken. So for fish survey, we are using visual senses with belt transect, and for coral covers, we are using point intercept transect. And so for this method, 100-meter transect line parallel to the shoreline was divided into 4 segments. One segment consisted of 20 meters, and in each of this segment, there was 5-meter space. And for fish survey, there were 2 observers. And so one person is looking at the right side for 2.5 meters along the transect and the other on the left. And for the point intercept transect, the data was taken at every 50-centimeter interval. And so for the surveys, during the first surveys, we surveyed 2 locations at 2 different depths. which were 3 and 6 meters. And so in total, it gives us with 4 transects, while in the next survey, the data was only taken in one location at one depth, which was 8 meters. So it gives us only with 1 transect. And so this is the fish survey that was done. This is the data. The identification level is up to family names. And just by looking at this really quickly, we can see that the number of fish taken in the first surveys was far greater than the one in the next survey. For example, there was 170, and then the next one there were 4. And this might be because the fact that the first survey, the data, it had more transects, and therefore there were more data collected. And next is the percentage of substrate covers. And we are using the identification from Reef check. It is the lowest identification. And so here, what we really want to see is the hard corals covered. And as we can see, the first survey, it was 28%, and the next one, it was 49%. And if we didn't know how the data was taken, we would think that, oh, wow, in just 6 months, like the coral covers, it rises up to 20%. However, this is definitely not the case, because due to the differences of the data collection. And so with this, we want to know, are the methods suitable? So the current method is with visual senses with belt transect. And the limitation of this method is that the chance of bias can be quite considerable depending on the observers. It is standardization because different observers may observe different types of fish, and also they may have like different ways to count. But the advantages of this is that it only requires simple equipment, and it doesn't require a lot of people. And in Biorock, Indonesia, the surveys usually last less than a week. So we want a method that is efficient, because we have time constraints and also the budget is limited. And so for this, the method is good because we can measure other biological parameters such as invertebrates and also coral covers. And next, for the coral covers, we have point intercept transect. It can overestimate coral coverage. However, we can prevent this by having more points. So we can lessen the space. Now we are using 50 centimeter per point. But next, if we want to make it more details, we can make it into 25 or even 10 centimeters, for example. And the advantage of this method is that it gives the best estimates. It can give the best estimates as long as it has sufficient points. And it is good to measure coral conditions in general. And it's also time efficient, which is needed during the taking of the data. And so based on the sources that I found so far, what can be improved are the sampling design and also the level of identification. And so based on the literature found so far, for fish surveys, mostly they are using 25 meters transects with 5 replications at 2 different depths. And also 50 meters long transect with 3 replications at 2 different depths. And for coral covers, it ranges from 20 to 30 with 2 to 4 applications at 2 different depths. And so for now, I cannot exactly say that, okay, this length is the best or not. However, the sampling design really depends on, it primarily is driven by the logistical constraints and also the project goals. There is no one correct sample size or a sample area, as long as the area is represented, and also the sample size needs to, like the sample needs to be far enough from each other to be considered independent. And so we want to monitor changes from time to time. And what I can propose is that the permanent, having permanent transects might be efficient to detect any future changes that might come in the future. And next is the level of identification. So for now, the current method is using the lowest form of identification by reef check, and it can lead to a loss of information because currently it's only like hard corals, but we don't know what kind of corals that is, or we don't even know like what kind, if it's like acropora, if it's like branching, if it's tabular. And identification up to genus or species might provide us with detailed information. However, there are some limitations to it. We cannot apply it to Biorock Indonesia because identifications up to species or even genus, it requires someone from scientific background or at least someone with high level of expertise. And we cannot apply that because in Biorock, sometimes the ones who do the surveys are not only scientists, but also staffs that were given knowledge to monitor the coral communities. And so with that in mind, you can propose life form categories by English et al. Maybe implemented. And it might be not as detailed as having species, but at least we can know like what type of corals it's going to be. And also it might help in the future to for future references. And so to conclude, surveys are needed as a baseline and it's needed to monitor changes from time to time. However, guidelines are needed in order to have standard practices. Methods need to be following this procedure, these guidelines in order to have the best results. And here we are trying to find something that is suitable based on the resources we have. So we cannot apply something that is too high level of expertise or also something that requires a lot of time or money because there were some constraints. However, once we have the method, the best method, we should stick to it in order to be consistent and in order to have the best results. And before ending this presentation, I would like to thank Natasha as my supervisor and also the Biorock team, Yaman, Bang Begin, Bang Hawis, and Masiki, and also the MARRES team for supporting me and always helping me. Thank you.
Thank you, Aliyya. So here we go for the questions. You can drink a bit, and I invite you to put your mask back for the questions. As we started with Aldine and ended with Jean-Vincent just before, let's do it again, but opposite way. So Jean-Vincent, you can start the questions.
Yes, I have a question about the technology that you want to use. It's MAT technology, no?
The what, sorry?
This technology.
Mm-hmm.
Because
I think it's your...
It's the timer.
Yes, you were on time, currently.
Yes.
Because the title says the future Biorock Indonesia coral reef rehabilitation. So I mean, you want to put this technology in that site, right?
Yes.
So about this technology, can I use it maybe in a brackish environment?
In what, sorry?
In a brackish environment.
Can you define brackish?
Yes, sorry.
A mix between the fresh water and seawater.
So to be quite honest, I am not really sure if it's applicable or not, because the technology itself, it relies on the electrolysis of the particles in marine waters. And so I am not sure if it's applicable to having like brackish waters.
I have a second question.
Yes, you can.
So I'm wondering if it's possible to use some citizen science to have more data.
Yes.
And so did you estimate the individual variability of the simple efforts or the simple tests?
Yes, it is possible to implement citizen science. In fact, it is why we made the method simple as well, because in the future, we want to be able to have someone like local people to be able to help monitor the changes. And so, yes, it is possible for citizen science to be applied.
Thank you. So we'll go for Nina, and then it will be Stefan.
Yes, thank you very much for that presentation. That was very interesting. I have a question. So you want to basically improve the guidelines and the methods to monitor the area, right? So the method that you now introduced, that's Reef check, correct?
The identification, yes.
Yes. Okay. So why didn't, or are you planning to also try other methods? Because I mean, if you want to improve it, then probably it makes sense to try different approaches. And what differences do you want to introduce? Now you talked about different transect lengths, for example, but do you have other variables that you want to introduce?
Yes, I mean, the method itself, like, for example, I was thinking about having the underwater photo transect. And so we are, how do you say, like using photograph. And so when we were in the water, we take less time, but then we need someone to be able to analyze the data after that. And because this project is, how do you say, sometimes we have limitation of people. So sometimes we have people from scientist background, but also sometimes it's people from non-scientific background. And so we want to find a method that is the easiest, that can be implemented by a lot of people from different background. And so yes, changes of the methods can be found, but can be implemented. But then we want something that can be implemented at every project. And so we want to make sure that even if we change, can we implement it in other projects, for example, because at every project, the people might be different. And yes.
Okay, but if I may ask that as well, so how do you measure the best method in that sense? Because you say, I mean, you want to have something that you can implement everywhere. How will you find that?
I guess we can do it like with general. So it's not like we're deciding, okay, the transect needs to be 20 meters or it needs to be 25. But I guess it's more like general. For example, like we need the transect to be at least at 2 different depths, and we need the transect to be at least in every side of the island, for example. So we can say that for the transect. So instead of saying like the exact number, we can have it more general, but then you follow that because the point is we want to make a before-after comparison. But if the things are different, for example, like in one project to one project, okay, it can be different, the method itself. But in this one project, you need to have the same method in order to be able to have like a before-after comparison.
Okay, thank you.
Thank you, Nina. So we're going with Stefan Roberti and then Florian.
Okay, thank you for your presentation. It's not easy to find questions because you don't have real data, so it's not easy for me to find questions. But it's a very interesting matter, especially how you... do you have any clue how you will make local people able to analyze transect or conduct transect? Do you have any idea, like basic graphic of fish species or so on? Do you have any?
Yep. So for so each of Biorock Indonesia's project, we try to include local people as much as we can, because we know that they are the one who lives there, so they are the one who's going to take care of them. And so what we try is to involve them as much as we can. So yes, we can teach them to, how do you say, like to help us with the taking of the survey. For example, last time for this project, during the first one, we involved local people to help study diving. And so it might help them in the future for coral reef rehabilitation. And yes, we can have classes as well to teach them like about coral reefs. That's why like the method needs to be simple. And yes, in the future it can be implemented, because right now we are building, how do you say, like we are trying to build their capacities. And so yes, in the future it might be implemented.
Okay. And just a
really short one.
no, it's fine.
It's fine. Okay, Stéphane. Let's go to Florian, and then it will be Steve. Florian Briand.
Yes. Thank you for that interesting presentation. I had a quick question, actually. Looks like I'm no expert, but it's like trying to monitor and compare different like survey days, different methodologies. So yes, I understand it's very important, and it's crucial to have like a common methodology, to have like a baseline study, basically. But looks like all corals, you know, basically like the growth is based on every site is very specific in terms of topography, bathymetry, in terms of water quality. So I was wondering if there were existing databases around that you could check for the evolution of the water temperature, for example, or parameters like that. And if not, and if you were not budget limited, of course, what parameters would you try to measure? I mean, if you had like to install some sensors, what will you do?
Okay, so like if I understand the question is what parameters I would like to implement beside
yeah, are there any data that you can look around? Because if you try to compare one site with another, I mean, yes, but every site is specific. You know, the water temperature is not the same, the turbidity. I mean, bunch of you know, like physical parameters.
Like for this specific sites, no, I couldn't even find like if someone did research or not in this area, like this village specifically. Like there are still no research, and so we are unable to compare the data we found with someone else's data. Well, probably we can look it up for parameters such as temperature. We can look it up through remote sensing or something like that. But if it's like the physical data, no, that's why as well, like it's really important to have a guideline so we can compare the changes from time to time.
I think it's interesting, you know, for the guidelines, maybe you can divide in terms of budget, you know. High budget, you can do a bunch of like photogrammetry, for example. And if you have low budget, yeah, you can use like scuba diving like surveys. You know.
Yes, because it's true, like the budget is really limited, like for one survey, like for 1 year. If I can convert it in euro, like of course it's going to be different between Indonesia and in France, but it's only around like 4,000 to 6,000 for that 1 year program. And so yes, like it's really limited what we have.
Cool, thank you.
Yeah, thank you, Florian. Monet is important. So we'll come here on site with Steve, and then for Eric.
Just a first question, very small. You said you started your internship a bit late. So when was that? Just for the context.
It was in March.
In March. Okay. Yeah, I have to say I didn't really fully understand what you're trying to do because I mean there are a lot of different manual guides on how to do surveys on Reef. So are you like mostly trying to do like a look into the bibliography and try to find out what are the best methods that you could use, or are you going to do then the next steps to do some tests of the different methods and compare them? Like
Yes, I'm going to do with bibliographical work. Well, in fact, like what I'm making in the internship itself is making standard operating procedures. And so it's not about just the fieldwork data, but I'm just taking one aspect to do it for my thesis. But in the internship work itself, it's for a lot of topics. So it's for the fieldwork data for the biological monitoring, for the socioeconomics monitoring, to make proposal, to have introduction to Biorock, to make how to make monitoring and evaluation. So it's really broad. And so yes, I will do bibliographical work. And so that's why like but to how do you say like to make it more specific, I just decided to showcase the biological parameters here.
Okay. And I have another question, if I can.
Yeah.
Sure. So the survey method that you presented are all like, I would say on like pretty big, like spatially scale.
Mm-hmm.
But when I look at your photo there, it's a very, it's very localized project of Biorock. So how do you deal with that, with like comparing on like, large scale surveys with the effect of like local, management?
No, like the survey itself is locally. So like we have different projects, and like each project we do the survey. And so what I mean by comparing here is comparing that, but from time to time. So in a local scale, but from time to time.
Thank you, Steve. So we'll go with Eric and finally with Aliyya.
Thanks a lot for your presentation. I'm coming back to a little bit of questions and comments that were made from my colleagues. And you mentioned over several times that the budget is limited. Now, if you forget really the budget, okay, and the question that you ask here, what would you do? You did some literature research, you found some techniques that are interesting. So what would you propose to do to have something that you can do on whatever side that then is comparable?
Well, I would say like to make it more specific, we can do the underwater photo transect, and also like we can have like eDNA, like trying, like I'm not really in how do you say, like I don't know much about this method, but in fact, like during the last project we did, it was in Jakarta, like around Jakarta waters, and we are trying to implement underwater photo transects and also eDNA, but it's not yet how do you say, like it's only the first time that we've been doing it, and so we don't know if we are able to implement it in the future or not, because again, like it really, for example, if the project is located far away, for example, in the eastern part of Indonesia, and there would be no lab to, how do you say, to assess the data, then it's going to be hard to do.
Okay, actually you well, answered with something that I had in mind. So, and that's what I said, if you don't have any budget problems, because there are means of doing sequencing on the beach, the little machines. And where I want to go you is that you are within the MARRES program. So there are a lot of different teams that are associated to it that have different expertise. And I think it's not only having your own limited budget, which I think everybody has to deal with, but you have a big network of potential collaborators in Indonesia, outside. So this is also something that can be imagined, and the expertise may lay somewhere else, but can be sort of provided to, and this is in a context of collaboration. So I think you are for me in a fantastic program where you have the pool of people. So keep that in mind. That's a sort of comment in regard to your answer. Thanks a lot.
Thank you, Eric. We will conclude the questions with Aliyya.
Hi, Aliyya.
Hello.
Thank you for your presentation. So if I understand well, so at the beginning, the company gives you two different sets of data. I mean, from two different protocols, okay, that you had to compare. So from this comparison, what were the most comparable data and what were the most different one? And from that, what do you think it's crucial really to improve right away in the current protocol?
Okay, so The one that is comparable probably it's not something that I mentioned in the presentation because like I didn't have really lots of time to really put it here. But the one that is comparable are the data for invertebrates. But the one that were really different is the number of transects that they put, and so like the number of the number of effort that they put is not the same, and it's really affecting the data itself. And yeah, for example, like the data for fishes, as we can see, because of the different different amounts of effort, we can really see the difference between the data for fishes and also for coral covers, and also other data such as like the socioeconomic survey, for example, like they also measure different things. So it's like they don't have the same sampling effort, like it's the same method, but they don't have the same sampling effort. So I think that needs to be changed immediately.
Okay, and when you have been on site, now you have been on site, you were lucky enough to go there. So what have you done, and how your experience from before helped you in what you did on site?
I think that before doing all of this, like the coral reef rehabilitation, I think it's important to know exactly what the people need and what the people want, and if they are willing to do the coral reef rehabilitation. Because we cannot do coral reef rehabilitation if the people don't even care. And we cannot just come in, okay, we want to do coral reef rehabilitation, but if the people are not willing to make an effort, then we cannot really do it. So I think it's really important to know exactly what the local communities need. Like they might need, I don't know, they might need something other than coral reef rehabilitation. And so I think it's important to understand the locals first.
How do you plan to include the local people in this kind of project?
Sorry, okay. So that's the last question, and if you can answer it quickly.
Yeah. And so we can include this by, for example, like usually in villages like this, they have local communities. They have communities for young people, and also they have communities for people who care about the environment. And we can involve these people to help us with the coral reef rehabilitation, and that's actually what we're doing.
Okay, we're going to conclude here. Congratulations, Aliyya, and also good luck because you still have some work to do.
Yep, thank you.
And see you soon. So good luck. You're staying here around, and we will continue with Florina Jacob. She will also talk about restoration. She worked from Paris, but the site was Indonesia as well with Coral Guardian. This presentation contains confidential material, so we are going to do this private. So we will stop the YouTube live, and we will come back on live with Matthias and Richard, who will talk about more ecosystem services, and this will be around 3:30. Yes, it's hot. Hello. Vas-y, je t'en prie.